Okay, next hazard we need to talk about is volcanoes. So again, yung what to do before, during, and after an earthquake is a primer from Pbox, which I will upload and paki-review na lang. It's better na reviewin nyo siya or you have that with you para alam nyo kung anong gagawin. Okay, so definitely part yun ng exam. Now we go on to the next hazard, living volcanoes or volcanic eruptions. So just some review ng terms. Magmatism is the formation of igneous rocks from magma, magma being the molten material beneath the earth. When this molten material reaches the surface and crystallizes or flows out into the surface, we call that lava. Okay? Yeah. Plutonism, on the other hand, is the intrusive igneous rock crystallizing at depth, which basically represents yung magma natin slowly cooling down since it's given enough time basically to cool down. Imagine, for example, a hot ice kite, ice is cold. Any material that is warm, that is too warm, or molten material, molten glass, for example, if you subject it to sudden change in temperature, it cools suddenly. So yung opposite nun would be letting the hot material cool down gently or through time in an environment that is naturally warm then. So that is the case for magma crystallizing at depth sa Earth. Okay, and then volcanism is all the phenomena resulting from and causing magma within the crust or mantle of a planet to rise through its crust and form volcanoes on the surface. So volcanoes represent basically the conduits. They represent the channels through which lumalabas yung magma natin papunta sa surface. Ano bang ginagawa ng magma? The magma represents the heat from the depths of the depths of a planet. So yung heat transfer from depth papunta sa surface, that is basically volcano. Right? Magma sa Earth is a silicate, meaning it's dominated by SiO2, silica. As the magma rises, the magma rising to the crust, bonding and reaching the surface, forms volcanoes like this one. And this is, since nasa surface na siya, this is what we refer to rather as a lava. Yeah. Okay, so saan ba nag-generate ng magma? As you know, yung crust natin or lithosphere natin, most of that is solid. There are only specific areas where volcanoes are active. So I won't go into the details too much, pero if asked saan may volcanoes, basically there are three main areas kung saan nagkakaroon ng volcanoes. We already met one when we have compressions like this or when we have subduction like this. We have this material here going beneath the earth, and yung fluids from this subducting slab actually induces the melting of the overriding mantle material. Okay, so this is again crust, mantle, yeah, and then sa ilalim pa yung core. Naturally, yung mantle natin is very hot, but it's solid material, sabi natin, di ba? So it's hot pero it's solid. But if you add water to that hot, solid material, it starts to melt. And that is what happens kapag meron kang subduction. So imagine, ito yung crust natin. Dati, bago yan siya bumaba dito siya sa surface, and yung sediment or yung minerals basically in this rock or comprising this rock basically incorporates a lot of water. Once it's compressed at depth and heated, it starts to release that water and starts producing magma or induces melting dito sa mantle material. Once nag-start na siya mag-melt, then you have volcanoes sa surface. Okay? Ano bang natin? Isipin natin. Wala kang maisip na material na mas madaling mag-melt pag may tubig. But in terms of rocks anyway, so for example, granites, o kaya any rock in general, if you add water you decrease yung temperature required for that rock to start melting. Okay? And at the same time, you can also melt rocks even if you don't add even if you don't add water to it by simply depressurizing it, yung adiabatic decompression na tinatawag. So this mantle material is relatively hot, mainit siya in the first place, solid, pero once you release yung overriding rocks, yung rocks na nakapatong sa kanya, so pressure is much lower but the temperature is the same. Pressure, so if you have pressure and temperature diagram, basically, so just imagine pressure is here, increasing that way. Temperature is increasing this way. Okay, so naturally, if you have temperature is the same, pero pressure is the same, pressure is decreasing, pero temperature is the same. So something like this, mataas yung temperature, pero bumababa yung pressure natin. So this process, adiabatic, same pressure, decompression, also results to volcanism, the volcanoes forming. Okay? Sorry. You don't have to memorize basically kung bakit. For geology majors na yun. Geology majors, pero for the G course, basically, yung important thing to note is that ito yung two ways how we start melting. And of course, the third way to start melting is if you simply heat something up more than it can hold, then it starts to melt. And that is what happens in hotspots. Okay, so hotspot volcanoes, mid-oceanic regions or spreading centers, and at the same time, volcanoes, arcs generates volcanoes because of these processes. Okay, so volcanic eruptions, they're governed largely by physical and chemical characteristics of the erupting magmas. In general, if this is a basaltic magma, basaltic magmas are high temperature magmas. Silica content, mas lower yung silica content itong magmas natin. Siguro hindi for the purposes of Geology 1, kahit hindi na in detail nyo ma-remember itong types of lavas, but more of kahit yung most basic lang. So what we have is the felsic. This is the felsic, rhyolitic lavas, and the mafic is yung basaltic magmas. What's the difference between a rhyolite and a basalt? Most of what determines yung physical properties ng magma natin is just two things. Okay? Amount of silica at saka yung temperature ng lava natin. If the magma is high in silica, 68 to 77, for example, for felsic lavas, it becomes more sticky and more viscous. Para siyang toothpaste. In terms of consistency, imagine this as a toothpaste. So it's cooler also, generally around 900 degrees Celsius. Of course, it's still hot, pero it's much cooler compared to what we have on the other end, yung mafic lavas. So mafic lavas have less silica, making them less viscous, and at the same time, they're also hotter, around 1000 degrees Celsius. So in terms of viscosity, para silang honey. So this is a honey type. In terms of viscosity, para siyang honey in terms of viscosity. So hindi siya, nagko-flow lang siya easily. Ito yung nakikita niyo sa videos na Hawaiian lavas o kaya yung mga pinapanood lang na lava flows na hindi apparently deadly unless of course you touch it and it's too hot of course. Otherwise, yung felsic lavas natin are much cooler and nandun lang siya, much more silica rich. So in terms of viscosity, it's very resistant. Yeah. So aside from the lava flows, as you would imagine, and as you've seen sa pictures, most likely, mga tao sa Greenland o sa Iceland na nagba-barbecue lang habang may volcano na pumuputok sa backyard nila, most of those is because yung lava flows natin are low, although low viscosity siya, even this low viscosity runny lava is not fast moving. Okay? Hindi yan siya gumagalaw ng tens of kilometers per hour. It's very slow moving. It's hot, pero as long as you keep distance, it's relatively safe. What's more deadly is actually yung pyroclastic materials that is erupted together with this lava flows. Okay? Yan. So for example, when Mount Pinatubo in 1991 erupted, yung pyroclastic ash na nilabas niya is this one. Itong pyroclastic ash um, they represent basically a mixture of magma din, or lava flows din, and at the same time, uh, high, very fast or very rapidly cooled lava material, which are then fragmented, and we refer to that as the pyroclastic material. So for example, itong explosive eruptions are characterized by these pyroclastic materials being erupted together with lava flows. Non-explosive eruptions are generally marked by by the lack of pyroclastic materials, and instead what you have are just these lava flows and at the same time lava fountains. So this is the lava flow, and as you can see here, ito yung lava fountain natin. So yung gases trapped within the lava actually produces or actually powers yung pagiging explosive ng isang eruption. So here, for example, meron pa siyang gas para puputok-putok because of the gases. Now, imagine itong part na to having more gases. So, kapag mas marami siyang gas, mas marami siyang fuel, and itong lava material na nilalabas niya gets more and more fragmented. At the same time, the more violent the eruption, yung surrounding volcanic material, yung surrounding volcano edifice, we call that volcano edifice, yung surrounding volcano edifice can start um, dito can start collapsing as well. So pag nag-collapse yung surrounding volcano edifice, then it's also another material that can power or that can be fuel, basically, or be the material that gets erupted or that gets thrown uh, outwards by the gases. So yun yung nagko-comprise itong pyroclastic rocks natin. So pyroclastic rocks is a mixture of this basically lava flows that is rapidly cooled, and at the same time volcano or pre-existing material that gets recycled essentially. Okay? Now think of this cloud. Itong cloud na to is powered, as I mentioned before, by the gases being exhumed or be emitted in these lavas. Once those gas, para siyang yung tambucho, you think of it as tambucho, yung air na yon. So once all that air is lost, yung cloud na to collapses. And once it collapses, it produces basically what we call density currents. So just think of it as rapidly moving cloud, pero hindi siya talaga cloud, it's cloud composed of molten material together with recycled volcanic materials from the volcano edifice. So that is what we have that is yung cloud na yon, pag nag-collapse na siya, that is what we call pyroclastic flows o kaya pyroclastic surges, depende sa type ng movement niya. Hindi naman lahat ng material gets deposited in such clouds, fast-moving clouds. Some gets deposited farther away, basically settling as ash fall. Yeah. Ano ba to? Now, for the purposes ng Geol 1, you don't have to remember, you don't have to memorize rather, what's the difference between pyroclastic flow, pyroclastic surge, or ash fall, but you have to, I hope you understand kung ano yung difference nila in terms of movement. So, for example, you have this volcano. Yan. So, kasi, pangit na, wait lang ha, in color red. Yan. So, ito yung ating volcano. Pag nag-erupt siya, yan, erupt siya. Yung gases from inside the volcano pushes yung material outward. Okay? So, as long as may gas ka na nagpo-push outward, yung material in an explosive eruption is thrown upward. Yeah. And as it's thrown upward, it produces a cloud basically filled with ash, molten material that gets cooled very rapidly, so it turns into ash. Eventually, itong ash material na to, just because it's in the cloud, it starts to be deposited sa paligid niya. So, cool ash material in the surroundings, that is basically ashfall. Okay? So, ito yung ashfall materials natin. At the same time, itong ang column natin, itong sinasabi natin kanina na column ng gases, fueling itong upward movement, itong cloud, once nawala na yon, then this cloud can start collapsing and basically density current. So itong cloud moving downward, downslope nitong volcano natin, uh, rushes downslope, and yan yung tinatawag nating pyroclastic flow and at the same time pyroclastic surges. If this material and at the same time itong ashfall natin mixes with water, for example, rainfall, then that forms a soup, basically a soup of ash plus water, which we call lahar. Okay? Yan. So itong ashfall, pyroclastic flow, surges, lahar flows, all of those are basically filled or composed nitong pyroclastic rocks or fragmented rocks. Okay? Yan. Ano naman yung debris avalanche? So imagine, for example, you have a volcano like Pinatubo, for example. Originally, ganito katangkad si Pinatubo, but post 1990 eruption, some parts of it collapsed. So, yung isang part ng isang part ng bundok basically collapsing produces what we call debris avalanches. So, avalanche of material during or following an explosive eruption. So, yan yung debris avalanche. It's a section ng volcano that collapsed. Okay? Yeah. So kanina, yung types of eruption is in terms of explosivity. Explosive eruptions are again characterized by pyroclastic materials, and non-explosive eruptions are characterized by the lack of pyroclastic materials. Lava flows lang yung meron siya. We can also characterize yung type of volcanic eruption in terms of what material is involved. If it's magma, if it's material from the magma, then we call that magmatic. If it's basically, so yung volcano natin. So if you've been to Pinatubo, you know na yung surface niya eventually was filled with water. So may water na dito ito yung Pinatubo, for example. Pero beneath that water is still the magma chamber, basically molten material composed of magma. So here you still have a hot material, and then sa taas, surface lang. Sometimes, some of the water, through natural faults o kaya through natural systems, some of that surface water can interact with the hot magma, and because of that, it produces small phreatic eruptions. Geysers, for example, like the ones we've discussed before. So itong mga natural hydrothermal vents na to, they can produce what we call phreatic eruptions. Take note, these are still deadly, especially if you are on the surface ng volcano at the time na nagkaroon ng eruption. And because it's just the reaction between water and magma, it's more unpredictable. It's unpredictable kailan mangyayari. On the other hand, if it's magmatic eruption, then that involves magma rising to the surface and being exhumed outside. So itong magmatic eruption, meron kang magma releasing or magma release. Okay? And then phreatomagmatic eruption is the mixture of both. So meron kang magmatic material na umakyat sa surface and at the same time mixing or interacting with water, yung surface water natin. So that is phreatomagmatic eruption. Yeah. And in terms of explosivity, ito yung tinatawag natin nga kaninang effusive eruption. So pag effusive eruption, it's either Icelandic o kaya Hawaiian eruption. What's the difference? Icelandic eruption, yung vent is through a fissure. So, fissure, uh, lateral break sa rock. Tapos yun yung buong yun, doon lumalabas yung lava flows natin. So, that's an Icelandic type eruption. Hawaiian eruption, on the other hand, ay basically lava flows lang din siya, pero through a central vent. So, isang circular or isang vent lang yung nilalabasan ng lava flows. Kapag Icelandic, it's through a fissure. Strombolian eruption is the baseline or is the boundary between effusive and explosive eruption. So, Strombolian eruption is characterized by lava fountaining. Yeah, so lava fountains, as the name implies, fountains siya na lava lang. So, parang paisa-isang lava flows. It's dangerous immediately along the volcano, pero in terms of pyroclastic material, wala masyadong, hindi pa siya gassy enough to produce very explosive pyroclastic columns or very dangerous pyroclastic columns. One notch higher is volcanic eruption. So volcanic eruptions are, ito na, meron na siyang eruption column. So it can produce yung pyroclastic. If this collapses, it can produce na yung pyroclastic surge and pyroclastic flow natin. And at the same time, yung gases like this or yung ash material like this can start settling sa paligid. So meron ka na ring ash fall. Yeah. Yung large volcanic eruptions like the ones in like si Pinatubo eruptions, those are what we call Plinian eruptions. So Plinian eruptions are large volcanic eruptions. So mataas yung, it's basically sustained by equally gassy magma, usually more silica rich, so more of the siliceous composition, but not always. Pwede rin siyang mangyari pwede ka rin magka-plinian eruption sa basaltic magmas. Anyway, yung point lang is we call it plinian eruption kapag meron ka ng substantial eruption pyroclastic column like this. Usually, if it reaches the stratosphere, it's the boundary. So if the eruption column reaches the stratosphere, that means na yung amount of gases na nandito sa magma natin is too high so that it produces this much eruption column. Pelean eruption is a special type of eruption in that it represents or it involves breaching. So, imbis na dito lumabas yung lava flow, yung pyroclastic material natin, nag-breach nagkaroon ng breach sa conduit, and instead yung lava started pouring out through a side vent. And because of that, the pressure is still there. So yung gas release is still directed, pero imbis na upward, it's to the side, making it even more deadly. Yan. So instead of producing a eruption column like this, it just produced this thick cloud rushing down slope, basically a pyroclastic flow. Okay. Since this is a very hot material, again, even if it's felsic, it's up to 900 degrees Celsius. So it's very hot and it's very fast moving. So these are what we call, some have referred to this as the glowing gases. Very hot. Yeah. So in very gentle types are just the Hawaiian type. So it's just lava flows, very gentle, low level eruption. So it's effusive, generally found in basaltic lavas. Basaltic lavas, since they are, in terms of temperature, it's very hot. And in terms of viscosity, it's very low. So it's easily moving. And in terms of gas, mababa lang din yung gas niya. So if meron mang ash, it's very little. Strombolian eruption is, ito yung classic picture showing yung lava fountaining. So ganyan yung itsura ng lava fountaining. Usually, these are short-lived explosive eruptions. So you see here, this dark cloud, meron na siyang, kahit paano, meron na siyang eruption column. Not so much, pero meron na. It's usually parang Iceland and Hawaiian. It's usually basalt in composition, mostly producing what we call scoria. Yeah. Volcanic eruption is more destructive or is more explosive rather. So this one, for example, in 2009, usually involving highly viscous or a more viscous lava. If you go back to the chart kanina, it's mostly andesitic to dacitic rather than mafic or basaltic. Yan. And in terms of eruption column, yan yung marker niya, meron ka ng eruption column, pyroclastic column like this. Okay? Yan. Pelean type is characterized by sideways explosion. So eruption rather, sideways eruption, and that sideways eruption produces this thick, very hot pyroclastic gases or pyroclastic cloud rushing down slope. Yeah, this, for example, it's 1984 Mount Mayon. Although generally found in more intermediate to mafic, intermediate to felsic composition, it can also be found in basaltic lavas, or it can, yeah, sometimes pwede rin siya mangyari sa volcanoes with generally a basaltic magma. And of course, Plinian or Vesuvian type eruptions. These are the big volatile rich big eruptions, usually fueled by very volatile rich lavas. So digsites and rhyolites. Ito na basically yung felsic magmas natin. Yan. Okay, so 1991 Pinatubo eruption, for example, produced this thick eruption cloud that reached the stratosphere. Yeah, and then there's another subcategory, yung ultraplanian type. Ito yung very explosive eruptions na, usually involving volumes of materials of more than 10 cubic kilometers to 1,000 cubic kilometers. For example, yung 1883 Krakatoa eruption, supposedly producing the largest or the loudest noise ever recorded, supposedly by some accounts. Narinig siya halfway across the globe ng mga Britons, for example, British monks. So, ganun daw supposedly kalakas yung boom na narinig nila because of this earthquake. Because of this volcanic eruption. Yeah. And then there are other subtypes, Surtsean eruptions. Surtsean eruptions is basically produced from interactions ng water and lava, named after Surtsey in Iceland. In this particular eruptions, you had basaltic lavas interacting with seawater. Yeah. So, ito, mukha siyang pumuputok lang, pero solid rock na yan siya. It represents yung drastic formation ng rocks or solidification ng lavas into solid rock. You can also, of course, have volcanic eruptions beneath glaciers, and that is what we call that produces subglacial volcanic eruptions. For example, in 2010, I don't know if you were yes, conscious naman na kayo na. In 2010, biglang suddenly because of this eruption in Iceland, nagkaroon ng cancellation for several weeks or months ata, nagkaroon ng cancellation of flights, transatlantic flights from US to Europe because of these volcanic eruptions. In terms of explosivity, it wasn't so explosive, pero the gases or the ash produced by this volcanic eruption was dangerous or was deemed dangerous for jet engines. Yeah. So, yeah, phreatic eruptions, on the other hand, they only blast out fragments of pre-existing solid rock. So technically, walang magmang lumabas. It's just fluids, usually steam power produced from heated gas or heated water interacting because of this water interacting with magma deeper sources. Yeah. So ano ba yung products ng volcanic eruptions? Na-mention na natin before. First is yung lava flows nga. In terms of hazard, hindi naman siya super deadly unless of course you're on the path ng lava flow. It's very hot, yes, but it's very slow moving. So because of that, hindi siya ganun ka-deadly. There are two main types of lava flows, and pahoyhoy. named after lava types sa Hawaiian islands. So, lava flows are characterized by these broken lava blocks called clinkers. Ito yung itsura niya kapag hindi pa siya solidified, pero ito yung itsura niya kapag solidified na siya. So, parang siyang blocks of rocks which are very sharp. Yeah. And at the same time, they are usually of higher viscosity than Pahoehoe lava flows. It's usually slightly cooler than Pahoehoe lava flows. Pahoehoe lava flows are like this. They are still ropey and they are less viscous. So less viscous means they are generally more easily flowing. Yeah, and 1,100 to one slightly warmer than lava flows. Okay. Yan. So, ito yung ito yung lava flows na mayon. For example, during the 2000 something eruption. Yan. Ito yung Mount Mayon. And then, yung mas deadly actually is yung pyroclasts and pyroclastic materials, basically. Pyroclastic materials, which are generally grouped based sa size. If it's less than 2 millimeters in size, in diameter, we call that ash, right? Anything more than that, 2 to 64, we call that lapilli. And anything more than 64 millimeters, we call that blocks and bombs. Itong blocks and bombs, usually bombs refer to this type of material which was crystallized from lava within this cloud. So usually they look like this because they are crystallized within this gassy environment. They are usually filled with holes. Yeah, filled with holes like this. Yung ash naman, and at the same time, if we look at the material here, it represents broken crystal fragments o kaya rock fragments from the original volcano. Yun lang yung basically composition itong mga materials na to yung basically nasa loob nitong cloud na to na nakikita natin dito. So yan, hindi yan siya gas lang. It's usually filled with this materials like this right here. And yung ash, although it's fine, it's deadly. It's more hindi man deadly. It's more dangerous because since it's fine, yeah, it gets transported farthest from the source, especially if the eruption column reaches the stratosphere. So it's basically airborne, and because of that, yung lung problems is one problem that can induce. Another thing is that yung ash natin accumulating on roofs may cause, since it's relatively dense material, it can cause yung collapse ng roofs na yan. Para yan siyang snow piling up on roofs. Pero since this is ash, it's more dense than snow, so it can actually cause roof collapse. Kaya siya dangerous. If you're within the proximity of the volcano, of course, pwedeng yung mahulog sa'yo are bigger materials like this, bombs and blocks, which are obviously deadly. Yeah. And another thing is gases. Another danger is gases. So itong volcanic gases natin, if you're close to the source or close to the volcano, these gases can be very toxic. Yeah. Kita nyo naman dito, kulay yellow yung floor. Those are because of sulfur crystallizing sa surface. Yeah. Prolonged exposure to these gases can be very deadly. Yeah. And okay. So, how do we measure? Kanina dinidiscuss natin yung explosivity ng volcanoes natin. There is a more or less qualitative, based on quantitative material, quantitative evidence, pero it's a relatively qualitative measure of explosivity ng volcanoes. We call that the VEI, Volcano Explosivity Index. So it's based on the amount of volume. One of the parameters that is used is based on the volume of erupted material or erupted tephra. Tephra is basically pyroclastic materials. So if it's large volume of tephra, pyroclastic materials, for example, Pinatubo, that characterizes it as a very large explosive eruption. So Mount Pinatubo, for example, some put it at VEI 6. And it's not the biggest. There are even bigger eruptions. For example, in 1815, in Tambora, and Yellowstone in Yellowstone caldera which erupted 600,000 years ago. So yung volume ito is something that we can't imagine and hopefully won't happen in our lifetime. Yeah. So aside from the volume of the material that is exhumed to the surface, it's usually also based sa height of the eruption cloud. So sabi ko kanina, stratosphere. Pag umabot siya sa stratosphere, it's automatically mag VEI 5 and above. Okay? And at the same time, in terms of frequency, generally, as we said before, explosive volcanic eruptions are fueled by gas within the magma. So the more gases you have, the more gases the magma has, the more explosive the eruption is. And as with anything, taking in gas or accumulating gas takes time. So in general, larger volcanic eruptions takes longer periods of time, longer interval in between eruptions kasi they have to accumulate gases. For example, prior to the 1991 Pinatubo eruption, the last volcanic eruption that was recorded by Professor Newhall and others occurred about 500 years ago. So about 500 years prior to 1991 eruption, there was another eruption, and 500 years basically of accumulated gas, more or less yung nakita natin or yung nakita ng 1991 eruption. Yeah, and it's not even the biggest. Okay? And so ito yung parameters, yung classification. So plume height, for example, Pinatubo is grouped as some, put it at VI6, so colossal type of volcanic eruption with the plume height of more than 25 kilometers, volume height of about 10 cubic kilometers, and classified as plinian and ultraplinian. As I said before, sa Pinatubo, yung last known eruption niya before to 1991 rather, was 500 years ago. So the longer the interval period between eruptions, the more gases it can accumulate, and therefore the more explosive it can be. Yeah. Okay, I think we can end here. We'll discuss yung types of volcanoes in the next lecture. Okay. Sige, tapusin ko na lang din. Simple lang din naman itong types of volcanoes. The types of volcanoes, basically, they may be shield, cinder cones, composite stratovolcanoes, volcanic domes, and calderas. I-explain ko naman siya isa-isa. Simple lang. Yung shield volcanoes, they are mostly built by lava flows. So, lava flows, wala siyang explosive eruptions most generally. So, for example, in Hawaii, so this volcano is just one volcano, Mauna Kea, for example. Sa likod niya, meron pang ibang centers. Pero ito, isang buong isla halos, isang volcano lang siya. As you can see from here, it's shape of a shield in that it has a low profile, maliit lang yung height niya, pero it's very broad. So very broad, low profile, that is a shield volcano. Usually built by years or by several lava flows piling on top of one another. So lava flows piling on top of one another, lava flows are generally more viscous or less viscous than sila than pyroclastic material. Hindi naman nag-flow yung pyroclastic material in the first place, aside from pyroclastic flows. But anyway, lava flows, they are runny. They can move a lot. So because of that, they generally build this, or they generally tend to result in this low, broad profiles. So that is a shield volcano. In terms of size, the biggest volcanoes are shield volcanoes. Okay, so the biggest volcano, for example, so far identified is Tamu volcano. It's an offshore volcano. Actually, may contender na doon. Our very own Benham Rise. A section of that has been identified as a submarine shield volcano. And then smaller than shield volcanoes, and the ones that we know, yung mas characteristic na triangular shape are actually what we call composite or stratovolcanoes. Composite or stratovolcanoes, they're composite, as the name implies, is a mixture. So composite volcanoes are basically a mixture of lava flows and at the same time tephra, pyroclastic material. So it's alternating, di naman necessarily alternating year on year, pero it's alternating explosive and effusive eruption. Because of this alternating between lava flows and pyroclastic materials, it produces this steep profile that we know. Yeah. So ito yung Simayon, for example, that's a stratovolcano. Yeah. Yeah, ito klase mo yun. So, for example, here you have this most recent lava flows on top of this pyroclastic materials. Yeah, so that is a stratovolcano. Smaller types of volcanoes are what we call cones and as well as maars. So, ito ay basically shorter in terms of time frame, in terms of lifespan rather. Yung volcanic cones are generally represent single eruption events, single or mas dito, ephemeral na eruption events, usually shorter in terms of, hindi siya parang stratovolcano, which represents multiple periods of explos uh, multiple periods of volcanic eruptions. Yung volcanic cones usually represent a single volcanic eruption, which may span years or even months or even decades, pero they generally, once natapos na yung eruption, tapos na for good. Hindi na ulit mag-erupt sa area na yan. In general. Of course, there are exemptions, but in general, ganun yung difference ng volcanic cones and stratovolcanoes. And since one time, big time lang essentially itong volcanic cones, then generally, smaller sila. Hindi pala generally. Yes, they are much smaller than stratovolcanoes. Usually characterized based on size. So kung gaano ka laki yung material, yung volcanoes na yon, and at the same time based sa shape and material that it produces. So you can have spatter cones, ash cones, tuff cones, cinder cones. Basically they're all cones which states na which reflects yung kanilang periodic lang na eruption, and at the same time yung material they emit. Yeah, so Parikutin, Mexico, for example, this is an volcano that grew on the backyard of a farmer, and it kept on erupting for the next years. And eventually, once tapos na yung eruption, tapos na rin yung growth ni Parikutin cinder cone. And next is what happens, yung sabi natin kanina, what happens if you have a collapse ng volcano because of the explosive eruption. So what's left is usually a big crater that eventually gets filled with water, and that is what we call a caldera. May or may not be filled with water, actually. That is a caldera. So it's a large depression which is formed due to the collapse or during or after the collapse of a volcano. So for example, imagine nyo si Pinatuba dati, ganyan siya. Pero because of the collapse or because of the explosive eruption, this whole part got blown off. So eventually you're left with a much, yeah, volcano. And then eventually sa taas niya may cone na tumubo, actually, dome siya. So it's a small eruption, a small volcano on top of a volcano. So it's a dome. Yan. And ito yung caldera natin. Sa case ni Pinatubo. Sa case ni Taal, mas malaki yung caldera. And up to now, there's still debate kung gaano karaming large or volcanic eruptions yung nangyari to produce the whole Taal caldera, yung Taal Lake. It's basically one caldera. And on top of the new caldera, you have this new volcano growing on top of it. Yeah. And then, ito yung sinasabi ko kanina, dome. Usually, after a large after a volcanic episode or volcanic eruption, an explosive volcanic eruption, yung last magma is essentially very drained of gases. So it's a very viscous magma that's left, and usually it's exhumed to the surface as a lava flow, pero since super viscous siya, yan na siya. Parang siyang, yan, nandiyan na siya sa, mas stuck siya basically sa, it plugs in yung conduit kung saan dumadaan yung lava flow natin originally, or yung volcanic materials natin originally. Yan. So, parang earthquakes lang. Sa Philippines, aside from the shape of the volcanoes, we classify them based on their activity. Active kapag within the last 10,000 years, may known activity or recorded activity. Uh, Inactive kapag walang activity, and then potentially active kapag posibleng merong activity within the last 1.65 to 10,000 years. Usually, we know that there's still hot material beneath that bundok specifically. So volcano siya, hindi lang siya natural or hindi lang siya normal na bundok. Because there are other markers like springs. Hot springs, for example. Hot springs o kaya small vents kung saan lumalabas yung gases, which is easily seen. Ayan. So, gases like this, based on the chemistry nitong gases na to, sulfur, carbon dioxide, carbon monoxide, things like that, yung amount nun can indicate na you have a magma underneath. And if you have a magma underneath, hindi lang siya normal volcano. Kahit na wala siyang active or normal na mountain, kahit na wala siyang activity in the last 10,000 years, it's still a potential it still has a potential to erupt uh, in the future, kaya siya pina-classify as potentially active. Yeah. So this is a map of active and potentially active in pink as well as inactive volcanoes throughout the Philippines. And this is, of course, a function of the tectonic environment. Yeah, so we have 23 actually, 23 active volcanoes and more than 200 inactive ones. Most are subduction related, but exotic types also exist. Exotic types meaning hindi subduction related. Amugis volcano, for example, in Palawan, which is situated somewhere here. Okay, so si Amugis volcano medyo debated pa yung origin niya, what drives yung volcanism dyan. Pero anyway, an important point is that even if we don't count Amugis volcano, most of our volcanoes are related to related to subduction, both on the east or on the west, either on the east or either on the west. Yeah. Some of the notable eruptions sa Pilipinas would be yung 1814 eruption ni Mount Mayon, which resulted or which claimed 2,200 lives. Si Mount Mayon, yung most active volcano natin, it erupted 49 times in the past 400 years. Some eruptive events are more explosive than others. As I've shown before, yung most recent is just a lava flow. Yan. Minsan Plinian lang, minsan mas Vulcanian type eruption. Ito, for example, this is a Vulcanian type eruption. So ano yung hazards and risks related to volcanoes? Again, hazard refers to any potential dangers present in the area. Risk is any potential loss or damage the uh, because of the susceptibility or because as a function of susceptibility. Yung population, yung dami ng tao na nakatira doon, yung um, density ng population na nakatira doon, yung amount ng property na nandun, etc., etc. So this is risk versus hazard. So as we said before, as I mentioned before, lava flows are they are dangerous, pero unless nasa path ka nung slow-moving lava flow, hindi siya very deadly. Yung mas deadly is actually yung pyroclastic materials. These pyroclastic materials, long after the eruption, can be remobilized by water, and if they produce lahar flows, ito yung another deadly kumbaga hazard associated with the volcanic eruptions. So for example, during the Pinatubo eruption, there were no recorded deaths during the 1991 Pinatubo eruption. Pero if you look up how many died during the Pinatubo eruption, uh, Google or Wikipedia will tell you, or any other source will tell you, there were at least several hundreds who died in relation to Pinatubo eruption. Hindi yun yung eruption mismo, but it's more of the lahar flows happening post the eruption. So, Pilipinas, tag-ulan. Pag tag-ulan, yung in-erupt na ash or yung dineposit na ash around Pinatubo area, uh, plus water produces thick lahar flows. Thick lahar flows which basically destroys everything on its path. Aside from that, meron ding rare cases that poisonous gases, carbon monoxide, carbon dioxide, sulfur dioxide, which are dense and invisible and odorless. Wala yan silang amoy. These are odorless gases which can suddenly basically replace yung oxygen sa surrounding and slowly piling up, and it can it can suddenly turn dead. So we'll see some examples of that. Lava flows, of course, are deadly, pero since they are slow moving, generally they are not that dangerous. They are destructive, yes, but they are not that dangerous. Tetrafall also is dangerous, just because of roof collapse, for example, and at the same time, para sa mga tao na may lung problem, it can induce asthma, for example. Yeah. If you're close to the volcano, yung blocks and bombs like this can of course be very deadly. Yan, this is a picture, for example, showing yung this is a Boeing 787 earthquake. Na basically yung airplane, which basically yung tail niya, because of the weight of this ash which covered it, bumagsak siya. I mean, na-tilt siya pababa, na-tilt siya on its puwet. And kita niya dito yung cord supposedly pulling it down, pero na-tilt na siya papunta dito. So this is a picture actually, Clark Air Base, airplane located in Clark Air Base during the 1991 eruption. Apparently, the story goes that the pilot of this plane has already been told to move his aircraft kasi nga may palapit na, or they know na magkakaroon na ng volcanic ng eruption sa Pinatubo any day now. Pero yung pilot na to essentially refused to move his plane. Yan. Kaya yan yung nangyari. And yung point ng picture na to is that the danger ng ash is mostly on the weight. So it can cause roof collapse. Yeah. And for example, since it's far more in terms of distribution, it can be distributed toward farther distances. It can be more destructive in terms of roof collapse nga. For example, Tambora eruption. During the Tambora eruption, hindi lang itong 92,000 deaths, hindi lang naman yan tephra. Mixture na yun, pyroclastic ashfall, pyroclastic flows, tapos meron pang tsunami because of the collapse of this volcano, and yung collapsed part na yun ng volcano basically rushed into the sea, displacing significant volumes of water, which then produced tsunami waves. So some of this death toll was also because of that. Yan. And pero yung pinapakita dito is yung thickness ng distribution ng ash. So several kilometers, thousands of kilometers away from the center na, pero meron ka pa ring 1 centimeter ash na na-deposit sa mainland Borneo, for example. Yan. Sa Pinatubo din, since it reached stratospheric levels, it deposited ash much farther away, and during this time, sakto na may bagyo, parating na bagyo, yung bagyong yon interacted basically with the ash in the stratosphere and redistributed itong ash na to towards farther distances. And as we mentioned before, some events like this, volcanic ash, can actually reflect or they reflect sunlight, uh, which cools the earth significantly for a short period of time. For example, during the Pinatubo eruption, it cooled the earth for zero point 0.5 degrees, zero point 0.5 degrees for about 2 years. Yeah. And then yung mas deadly niya na or deadly na hazard associated with volcanoes is actually pyroclastic flows. They are very deadly because they're very hot, 1000 degrees Celsius, and reaching speeds of up to 700 kilometers per hour. So this is supersonic speeds and temperatures of up to 1000 degrees Celsius. So kung hindi ka pa naka-evacuate nung pumutok yung volcano, chances are maluluto ka ng buhay nitong pyroclastic flow na to. Yeah. For example, this is a unfortunate example. 1902 Mount Pelée eruption, France, kung kanino pinangalan yung Pelean eruption. So the eruption was sideways and all the energy, all the materials was basically pushed to the side. So it killed 30,000 people, essentially the whole town. Kasi yung pyroclastic flow na it produced uh, had speeds of about 670 kilometers per hour and temperatures of more than 1000 degrees Celsius. So it's a very hot and very, very fast moving. So ito yung mga bahay, yan yung mga structures dati. Wala na kayong makita, puro ano na siya. Yung mga columns na lang na natira. Yan. Ito rin yung reason kung bakit naging deadly yung uh, Vesuvius eruption sa Rome, ancient Rome, for example. We think it's also because of pyroclastic flows and surges. So, for example, of the 3 known survivors ng 1902 eruption, one of them was a prisoner. And the only reason kung bakit siya nag-escape alive and actually severely burnt yung likod niya is because he was housed in this prison cell. Yeah, so, bato. So, na shield siya basically from the most destructive effects ng hot pyroclastic ash. Ayan. Krakatoa eruption, ito yung original island ng Krakatau, and because of that very explosive eruption, a huge portion of the island collapsed, producing tsunami waves, and together with the pyroclastic, kung kunwari ikaw yung nakatira dito sa Krakatau Island, your choice is basically the sea or pyroclastic ash. So that's why it was very deadly. So it killed 36,000 people. Yeah. And then volcanic gases, it can be also deadly, especially if the area is close to the in areas close to the volcano center, can kill by asphyxiation. For example, in Cameroon, Lake Nyos in Cameroon, 1986, carbon dioxide is a dense gas and it's basically odorless. So basically sa valleys kung saan may mga communities, apparently naglalabas na pala ng significant amounts ng carbon dioxide itong Lake Nyos volcano na to. So yung gas na yon, since it's a dense gas, it traveled mostly sa valleys, eventually spilling into the banks. But since it's invisible, hindi mo makikita. Yung mga maliliit na animals or low animals like carabaos, they were the ones first died, and then eventually people also died because of that carbon dioxide asphyxiation. So dense gas, invisible, you don't see it, you don't smell it, and suddenly yung oxygen level just drops and it can kill people and animals. Yeah. And then, of course, you also have secondary volcanic hazards like lahars and floods. As I mentioned before, lahar is just basically ash added with water. And then floods also relating to, floods more of related to lahars. So, debris avalanche, this happens kapag meron kang collapse ng volcano ng isang sector ng volcano natin. For example, during the Mount St. Helens eruption, yung original volcano, a huge section of that collapsed. And if you are a community downslope ng volcano, imagine mo yung isang kalahati ng volcano or one-fourth ng volcano suddenly collapsing, then that's very destructive. So it's a mixture. It's not as fast moving as pyroclastic flow. It's not as hot as pyroclastic flow, pero just because it's voluminous, it's a large volume of rocks and soil and materials suddenly rushing or collapsing pababa, it's also very deadly. Take note that debris avalanche may not necessarily be triggered by volcanic eruptions. It can also be triggered by earthquakes, as we will see later. I mean, sa subsequent lectures. Yung directly related to pyroclastic materials erupted during eruptions or during volcanic eruptions is lahar flows. Lahar, which is a Javanese word. This is relatively cool and slow moving, 100 kilometers per hour, pero it's just like a river. So, parang siyang river flowing, pero ang difference niya is yung viscosity. So the viscosity of lahar flows is very high. It's like cement. So it's like swimming through cement. Kaya siya very deadly. So it destroys everything on its path, buries it in thick muddy sediment. So for example, ito yung original, kung titignan nyo itong mga puno, ito yung tao for scale. Titignan nyo yung height ng mga puno, yung taas niya na portion. So up to here, umabot yung lahar flows. Yeah, well above the height of this person, for example. So everything on its path basically was covered in mud. And yun yeah, yung viscosity niya is like cement, so you can't swim through a cement. So if you're stuck in that lahar flow, it is very deadly. And this is the main reason kung bakit maraming deaths pa din na na-record for Mount Pinatubo kahit na wala actually namatay during the actual eruption itself. So yung mga communities na bumalik na post the eruption thinking that it's now safe actually got killed by lahar flows. Because lahar flows is just ash added with water. So this is another, if your area is within or close to a volcano, mga Bicolano, for example, you should definitely take a look at the possibility of lahar flows. Generally, since it's flowing along streams, you just have to know gaano kakalayo sa streams and gaano kakalayo sa ash material that can destroy yung bahay or yung that can basically feed into producing lahar flows. Yeah. For example, Nevado del Ruiz, 20,000 it killed 20,000, 2/3 of the 29,000 inhabitants. Take note of the speed. It was very slow, 12 meters per second, pero you cannot move. You cannot swim through that stream, basically. So it wiped out the whole community. The second deadliest volcanic disaster of the 20th century. Ayan. And of course, the Philippines, yung Mount Pinatubo, Cabalantian tragedy. It killed hundreds of people, ito yung sinasabi ko kanina, because it produced 8-meter thick lahar flows. So ito nakikita niyo dito, yan roof na lang yung kita, and here ito yung sediments na naiwan after the lahar flow na. So imagine yung water height is even higher than this one. Anything you see here is already buried. Buried na yan by land. Wala ka ng by soil basically. Ash material. So wala ka nang mababalikan dyan. Yeah. Okay. So that's it for today. Again, as a Philippine setting, ito yung two main, aside from typhoons, ito yung two main typhoon-related hazards like flooding. Ito yung two main hazards that poses risk or that we must face and we must assess kung ano yung possible effects niya sa communities natin. So, for the activity on hazard assessment, please look up some volcanic eruption or volcanic-related hazards and earthquake-related hazards.